Today we're going to continue our investigation into volume. Today we're going to talk about how cones and cylinders are related. It's kind of different. When you think of a cylinder, you think of a round circle that has a big hole in it, just like a can. But an ice cream cone doesn't have a hole in it. It comes to a point. Well, let's find out what they have in common. So in our cylinder, I've given you two examples. I have a cylinder that has a 10 centimeter diameter. Remember, radius is only halfway across. Radius is only halfway across. So if you see an indication of all the way, you need to divide it by 2 before squaring it. So in both cases, my cylinder has a 10-inch or a 5-inch radius, and my cone has a 5-inch radius. Remember, divide it in half because the radius is only this part. Radius is only halfway. So I'm going to give you the volumes of both of these. In the first case, my volume in my cylinder, I'm not going to tell you how I came up with these because we're going to talk about how and why they compare. In my first case, I have a cylinder. It has 863.5 centimeters cubed. 863.5 centimeters cubed. In the other case, my cone has a volume of 287.83 centimeters cubed. Now, just looking at numbers, maybe you can figure it out, maybe you can't, but we're gonna work on it. Here we go. So let's look. In my cylinder, remember our formula is height times the radius squared times 3.14 or pi. So in other words, this cylinder is volume is 11 times 5 squared times 3.14, which gives me the volume of 863.5. This is important. This is an important piece to remember. Remember, radius is halfway across. Square the radius. Multiply it by pi. Okay, so now let's look at the next slide. So how do these things compare? Well, early on I told you that my cone has a volume of 287.83 centimeters cubed, and the cylinder is 863.5 centimeters cubed. Let's try and find something out. You know, when we were comparing things in the past, we used what we called ratios. And a ratio is when you compare the size of one by dividing it by the other. So let's divide the big one, 863.5, divided by the small one to find the ratio. Well, if you plug this into a calculator, you're going to find out that that number is exactly 3. What? Exactly 3. It's kind of crazy, but it is. It's exactly 3. Okay, so that means for every 3 of these, there's one of these. Maybe that makes sense. If not, guess what? You're going to see a video later on to confirm it. So let's go back. Here we go. A cylinder is 3 times the size of the cone, or the cone is 1/3 the size of the cylinder. Like I said, you're going to watch a video proof of this during the lesson. So you're going to see how these actually relate extremely well. So therefore, our formula for a cone is the volume of the cylinder times 1/3. Now, how do they actually compare these? Because in a cone, we have a height interior and a height outside. Well, let's go back to this slide, and I'm going to show you what that means. Well, my interior height, if I were to drop line from the top straight down, this would give me my interior height. We call this the outside is called a slant height. Why? Simply because it's a slanted line. So we have this height, there's my slant height, times 3.14. Let's go back to the formulas. I have the interior height times my slant height times my 3.14, which is my radius squared. So this gives me what I need to find out my interior. So let's see. We remember, plug it into a calculator. I get 1/3 times, going back, my height is 11 times my slant height, which I don't know, but I use times my radius. We actually don't use the slant height, we use the radius. So 11 times 3.14 times 5 squared gives me 287.83. So let's go back to the last segment so that we can look at it. We have 1/3 the interior height. We do not use the slant height. I put that on there thinking that I was looking at it right, but I didn't. That's not right. It is times the radius squared times 3.14. I just wanted to see the difference between the slant height and the height. We always use the interior height. Remember, in the example shown, we have to divide the diameter by 2 because the radius is only halfway across.